All right, so your test is on Tuesday. So the first question here says, determine the domain, range, and intervals of increasing, decreasing, and constant. So out of these four, which one do you guys want me to do, A, B, C, or D?
Can you do A?
Yeah. So remember, our domain is all of the x values. So we look at our graph. If it doesn't have a dot, that means that it's an arrow and it goes on forever. So our lowest, our smallest x value here, since our graph goes on forever in the negative direction, our domain starts at negative infinity and then it goes on forever in the positive direction, so it would end at positive infinity. Our range is the y values. So we start at the bottom and then work our way to the top. So our graph starts at y is -4, so it starts at this point. Would we put a bracket or parentheses here?
Parentheses.
Parentheses. So this -4 is not included in our graph, so we would put parentheses. And then as we go up, our graph continues forever in the positive direction, so the end of our range would be infinity. Next, we have increasing. So remember, increasing and decreasing always has brackets, and it's always the x values. A lot of people got this wrong on the quiz. So just think, you start from the left, just like how you would in reading. You start from the left and go to the right. So if you were a person here, are you walking downhill or uphill when you start from the left and go to the right?
Down.
Down, so this would be decreasing. So our graph starts off decreasing, and what would our interval be here?
Positive infinity to 1?
So we
Or
start with the lowest value, so our smallest value here would be negative infinity.
negative infinity?
Yep. So negative infinity to 1, and we always put parentheses for decreasing and increasing.
Got it.
So
Wait, why wouldn't it be positive? Because isn't since the line's going like up though, like it's going like that.
we don't even pay attention to the up and down part of it. All we're looking at is our x values. So this is going forever in the negative direction for x. So we
Okay.
start with negative infinity.
All right, thank you.
And then we change once we get to 1. So now is our person walking uphill or downhill?
Up.
Up. So this would be increasing. So what would our interval be for increasing?
1 to infinity.
Perfect. 1 to infinity. So this goes forever in the right direction, which is infinity.
Ms. Carter,
Yes.
if the other arrow was an open dot, would that affect the domain? Because one's a closed and one's an open.
Right.
If we're open, would it change it?
So let's say that this one here was an open dot. That would mean that 1 is not included in our domain, so our domain would then have to be negative infinity to 1, and we put parentheses because it's not included, and then 1 to infinity. So this just says that that 1 is not included in our graph. So if they were both open dots, then yeah, we would have to write our domain like this.
Thank
Why
you.
is the increasing 1?
Because we start increasing at when x is this point here. So when x is 1.
And increasing and decreasing is always parentheses, right?
Always parentheses, and it's always the
Yeah.
x values.
Yeah. Thank you.
All right, any other questions on domain, range, increasing, decreasing, constant? But let's move on to the piecewise graph. So do you want to do A or B?
Can you do B?
Yep. Okay, so we always start by plugging in our parameters here. So we're going to start by plugging in 0. So we have f of 0 is equal to 3 plus x. 3 plus 0. 3 plus 0 is 3. So our first point on our graph is going to be 0, 3. And then since we have just a less than sign, that means we have an open circle there. So we go to our graph, we stay on 0 and go up 3 and put an open circle there. Next, we have to plug in another number that is less than 0. So since this says less than 0, we're plugging in another number that is less than 0. What's a number less than 0?
-1.
-1. It could be anything. I always like to pick the ones close to it because we won't get numbers that are huge. So we have 3 plus -1, which would be 2. So when we plug in -1 for x, we get 2 for y. So our next point, we go to the left 1 and up 2. And then we just connect our graph, connect those 2 points with a line for our graph. We know it's linear because we just have an x here. There's no x squared, nothing special happening to it, so it's a linear graph. So once we get 2 points, we can just connect them with a line. Everybody good with that so far?
Yes.
Okay. What are we going to plug in into our second equation here?
0.
0. We always start with what is given. So we plug in 0, and we know that this is going to be a closed circle. So we have 0 squared plus 1, which is 1. So our point is 0, 1. So we stay at 0 and go up to 1 and put a closed circle there. Now we see that this is an x squared graph, so it's going to be some type of parabola. So we may have to plug in more numbers to see what our graph is going to do. So let's just plug in a number that's greater than 0, so we can plug in 1. So we have 1 squared plus 1, which is 2. So our next point is going to be 1, 2. So we go to the right 1 and up 2. Now we can't connect these with a line because we know our graph is not linear. It's a parabola. So let's plug in another point to see what our graph is going to do. Let's plug in 2. So we have 2 squared plus 1, which is 5. So our next point is 2, 5. So we go to the right 2 and up 5. So our next point is right there. Now we can kind of see this curve going on, so we can just connect our 3 dots with what would be a parabola, half a parabola. Any other questions from the piecewise? You will have a piecewise function that you have to graph on your test.
Would 2 be linear for the piecewise? 2a?
Yeah, they're both linear, so this would both be straight lines. So for both of these, you would only have to plug in -4 and then a number less than -4 and -4 into the second one and a number greater than -4. So for each one, you would only have to plug in 2 points. All right, so going back to the ones that I skipped, let's take a look at number 1b. So our domain, again here we just need to pretend that these are arrows so that they continue on forever. Our domain goes forever in the left direction and forever in the right direction, so this would be -infinity to infinity, or we could say all real numbers. Our range, we are looking at the y values, so we start down low and go up to the top. So our graph goes forever in the negative direction, so it starts at -infinity, and then our highest y point is 4, And we have a closed circle there, so we put a bracket. Next, we are looking at increasing. If our little person starts here, they're walking uphill. So we increase until we get to this point, and we're looking at the x values for increasing and decreasing. So from x is negative infinity to 0 is when we're increasing, and then we go to decreasing at 0 to infinity. And then we are not constant on our graph, so we can skip that one. C, our domain. So we start at the left and go to the right. Our graph starts at negative infinity, but then it stops here at -1. And it doesn't have an open circle, so we're just going to pretend that these are closed circles here. So our graph ends at -1, then it picks up again, so we'll put the union sign at 1 to infinity. Next we have our range. Our range, we start at our lowest y value, so our lowest y value is when y is 0. Oh, I messed up in the domain. So these are supposed to be brackets here because they are closed circles. So since in our range we have closed circles, we would put a bracket. And we're looking at the y values, so we start with 0, and then our graph goes forever in the positive direction up, so we would end our range with infinity. Next, our graph starts by decreasing. So our little person here, when we start at the left side of our graph, is going down. So we're decreasing from negative infinity to -1. And we always put parentheses for those. And then we pick back up with increasing from 1 to infinity. All right, for D, start with our domain. Again, we look at these as if they were arrows. On the test, it'll be clear, it'll give you arrows. So the domain goes forever in the left direction and forever in the right direction. So our domain is negative infinity to infinity. Our range, we look at our y values. So our graph starts when y is 2. And we don't have any circles there, so we're going to put brackets. And then it goes forever up, so our range ends at infinity. Next, we have increasing and decreasing. So our little person would start by going downhill here. So we start decreasing. Negative infinity to, this would be 1. So again, we're looking at our x values for increasing and decreasing. Then from 1 to 3, our graph is flat, so this would be constant. So we are constant from 1 to 3. And again, always use parentheses for increasing, decreasing, and constant. And then lastly, we end increasing from 3 to infinity. Number 2, sketch the graph of the piecewise. So we're going to start with our graph. We always begin by plugging in our parameters here. So we're going to plug in -4 into our first function. So this would be -4 plus 5, which is 1. So when x is -4, y is 1. So we go to our graph. We're going to go to the left 4 and up 1. And we put a closed circle here since it is less than or equal to. Next, we need to plug in another number that is less than -4. So we can plug in -5. So we have f of -5 is equal to -5 plus 5, which is 0. So our next point is -5, 0. So we go to the left 5 and stay at 0, and then we just connect these two dots with a line. So since it's just an x, it's not x squared, it's not square root, it's nothing special, just an x, it's linear, so we connect our 2 points with a line. For our next part of our piecewise, we're going to plug in -4. So we have 3 times -4 minus 4. 3 times -4 is -12. -12 minus 4 is -16. So our next point is going to be -4, comma, -16. So we go to our graph, we go to the left 4, and then we're going to go down 16. So about there. And then here we're going to put an open circle because it's just greater than. Now we need to plug in another number that is greater than -4. I always like to plug in 0 just because I think it's less work to do. So f of 0 is 3 times 0 minus 4. 3 times 0 is 0. 0 minus 4 is -4. So our next point is 0, comma, -4. So we stay at 0, go down 4, put our point there, and then connect these 2 points with a line. And that is our piecewise function. All right, here we have determine if the function is odd, even, or neither. So again, for even, odd, or neither, we plug in a number and its opposite. If we get the same thing, it's even. If we get opposites, it's odd. And then if they are totally different, then it's neither.
Miss Carver, can you do C?
Yeah, I'll do A and C.
Okay.
So here we can plug in, let's say, 2 and -2. When we plug in 2, we get 2 minus 7 times 2, which would be 2 minus 14. So this would be -12. And then when we plug in -2, we have 2 minus 7 times -2, which would be 2 plus 14, which would be 16. So these two numbers are totally different, so that means this function is neither.
Can you do C?
Yep. All right, for C, what numbers should we plug in here?
3 and -3.
We can do that. I think when I did the answers, I plugged in 9 and -9 just because I knew like what the cubed root of 8 was. So like 9 minus 1 would have been 8. But we can definitely do 3 and -3. So we have the cubed root of 3 minus 1, which would be the cubed root of 2. Then when we plug in -3, we have the cubed root of -3 minus 1, which would be the cubed root of -4. Are these two things the same?
No.
No. So would this be even, odd, or neither?
Neither.
Neither.
Carver, can you do B too?
Yep. Any other questions on this one? Okay, let's do B.
Did your answer change for when you put the 8 for C?
It was still neither.
Okay.
Because like I ended up getting a whole number when I plugged in 9, but then I got a still like the cubed root of a negative number when I plugged in -9, so they were different, still neither. Okay, B. What number should I plug in? So let's plug in 2 and -2. So when I plug in 2, I have negative 2 squared. So remember, this negative has to stay on the outside, minus 2. So 2 squared would be 4. This is negative 4 minus 2, which is negative 6. When I plug in negative 2, I have negative 2 squared minus 2. Negative 2 squared would be 4, and then we keep that negative on the outside. Negative 4 minus 2 is negative 6. So we get negative 6 for both of them. Is this even, odd, or neither?
Even.
Even. Any questions from even, odd, or neither? All right, let's move on to our combinations. So a lot of people had questions on this. I was going through what you submitted for the review, and a lot of people left this blank. So make sure you guys pay attention for these. So when we're adding our two functions, we just add the two together. So we have 7x minus 6 plus 4 minus x. Now we just combine our like terms. So we have 7x minus x, which would be 6x, and negative 6 plus 4 would be negative 2. So we get 6x minus 2.
Can you do D?
I'm going to do all 4 of these.
Oh, okay.
Or 5. 4. So now we're going to subtract them. We have 7x minus 6 minus 4 minus x. Since now we're subtracting them, we have this subtraction sign in the middle. We have to distribute it to the 4 and the negative x. So this would be 7x minus 6 minus 4 plus x. So we have to make sure we distribute that minus sign. Now we can combine our like terms. We have 7x plus x, which would be 8x. And negative 6 minus 4 would be negative 10. So 8x minus 10. And then when we plug in 0, we just plug it in for x. So this would be 8 times 0 minus 10, which would just be negative 10. All right, let's look at C. So for C, we're multiplying the two of them. And since they're binomials, that means we're going to have to FOIL. So we have 7x minus 6 and 4 minus x. So we multiply the first terms together. We get 28x. And then the outsides, negative 7x squared. The insides would be negative 24, because negative 6 times 4. And then the last ones would be plus 6x. And then we just combine our like terms. So I'm going to move the 7x squared to the front. So we have a negative 7x squared. 28x plus 6x would be 34x. And then minus 24. So that's what we get when we multiply our two functions. And then the last one we have to divide. So we have 7x minus 6 over 4 minus x. We can't simplify this anymore, but we just have to state that x cannot equal 4, because then we would get a 0 on the bottom, and we can't have that. Okay, I'm going to do the next one too. So for A,
Wait,
yeah,
Miss Carver, for D, you just left it like that?
Yep.
And just put that x can't equal 4?
yeah, we can't simplify this, so we just leave it like that.
Okay.
All right, for number 5A, we're just adding the two together. So this would be x squared plus 3 plus the square root of 7 minus x. We have no like terms here, so we can't do anything. We just leave it like this. For f plus g of 3, so we just plug in 3 into this. We have 3 squared plus 3 plus the square root of 7 minus 3. 3 squared would be 9 plus 3 plus, this would be the square root of 4. 9 plus 3 is 12. The square root of 4 is 2. So our answer here would be 14. So all we did was plug in 3 for x and solve. For subtracting, we have x squared plus 3 minus the square root of 7 minus x. Can't do anything more here, so we just leave it like this. Multiplying, we have x squared plus 3 times the square root of 7 minus x. We could just leave it like this, or we can multiply the x squared times our square root and the 3 times the square root, so we would just get x squared times the square root of 7 minus x plus 3 times the square root of 7 minus x. I would take this as a right answer, but in case it's multiple choice and you see this, just know that all they did was multiply them out.
On the test, is there going to be ones where you can't do anything else to it?
There could be. So like this, that you would just have to leave it.
Yeah.
So yeah, there definitely could be. Okay, so now for dividing, we have our f on top, so x squared plus 3 divided by the square root of 7 minus x. Now we can't get 0 on the bottom, so we have to say,
if you did, had you put a voice over Google Slides?
so we have to say that this cannot equal 0. So if we set it equal to 0, to find when it would be equal to 0, then we can say that that's our restriction. So we have 7 minus x. The square root of 7 minus x is equal to 0. If we square both sides, 0 squared is still 0. So 7 minus x is equal to 0. We can add x to both sides. So 7 is equal to x. So this is equal to 0 when x is 7, so we just have to say that x cannot be 7. But this brings us to our domain question that we have over here on the right. So let's take a look at this one. We have x squared plus 3 over the square root of 7 minus x. So we need to find the domain of this. When finding the domain of a combination, we have to find the domain of f and the domain of g and take what's in common in between those. And then when it's the division one, so f divided by g, we have to do the added restriction of this cannot be 0. So we have to check for 3 things here. We need to find the domain of f, the domain of g, and find when our denominator is equal to 0. And we have to include all 3 things in our domain. So what's our domain of f? So just the top here, we have x squared plus 3. Do we have any restrictions there?
No.
No. So what would our domain of f be?
So it'd be all real numbers.
All real numbers. So if we put that on a number line, it would be the whole thing, all real numbers. Now we have to find the domain of g. G is the square root of 7 minus x. What do we know about a square root? What can we not have under the square root?
A negative.
A negative. So this has to be 7 minus x has to be greater than 0 because we can't have a negative in our square root. So then to find what interval this needs to be, we just add x to both sides. We have 7 is greater than x. So x is less than 7. So x has to be some number less than 7 on our number
Would it
line.
not be less than or equal to?
Oh, you're right. Less than or equal to 7. Because if it's equal to 7, then we would get 0, which we can take the square root of 0. So yes. So on our number line, this would be I'm trying to think. Because if we had, oh yeah, that's right, never mind. So this is less than or equal to, so it includes 7, so we would put a closed dot there, and then it could be anything less than 7. So that took care of our domain of f, our domain of g, but the last thing we have to check is when our denominator is equal to 0. We said that it's equal to 0, we did that down here, that it's equal to 0 when x is equal to 7. So we can't have x is equal to 7, so this would have to be an open circle here because we can't include that 7. So what's in common between this blue line and the green line? What would our domain of f over g of x be?
It'd be negative infinity to 7,
Are we including 7 or not including 7?
including.
What did we just say? X cannot be 7.
Oh, okay, no.
So
Just
what would we put?
parentheses.
We would put parentheses. So the three things that we have to check are the domain of f, the domain of g, and when the denominator is equal to 0. And we have to include all three things of those in our domain for this question.
Can you explain one more time why we're not including 7?
Because we can't have our denominator equal to 0, so we would take the square root of 7 minus x, set that equal to 0. If we square both sides,
Oh,
this
and then
would be
when
7.
we plug that in, it's going to be 0. Okay.
Right, so then we add x to both sides, so 7 is equal to x. We cannot have 7 be equal to x because the denominator cannot be 0. So that's why we would put an open circle here, so we cannot include 7. So for this question, you always have to check three things. That is the domain of f. So this is 1, 2, and then 3. Because I want to do the domain of f of g. So first we need to find f of g. We take g and plug it into our x in our f. So this would be 1 over x cubed. We can simplify this just by taking 1 cubed and then x cubed. So 1 cubed would just be 1, and then x cubed in our denominator. For g of f of x, we would take x cubed and plug it into x in our g. So we have 1 over x cubed. Let me just leave it like that. To find f of g of 0, we would just plug 0 into our f of g. So this would be 1 over 0 cubed. We can't get 0 in our denominator, so we would just say does not exist. Or not possible, or does not exist, I think, would be the option on the test if it is there. Okay, next we have to define the domain of f of g. So when we find the domain of f of g. It's a little bit different than what we did for the domain of f divided by g. So for this, we have to check our input. So we check the domain of our input. That's 1. And then 2, we need to check the domain of f of g. So here we only need to check 2 things. So looking at our g, we have 1 over x. What would our domain be here for 1 over x?
Well, x can't be 0, so
Right.
it have to be greater than
So it could be
1.
it could be anything except 0. So we would just put a hole here at 0, and it could include anything to the left on our number line and to the right. So it just cannot include 0. Then we need to find our domain of f of g, which we said our f of g is 1 over x cubed. What would our domain of f of g be?
It would be all real numbers.
Remember, we can't have 0 in the denominator, so it would be the same thing as our domain of g. So we would just put a hole at 0, and then it's everything to the left and everything to the right. So it's everything but 0. So
The
now,
exponent doesn't mean anything.
not really, because if we had 0 cubed, that would still be 0. So here it doesn't. Like, we can still we would just set x cubed is equal to 0, because we need to find when it does not equal 0. We would take the cubed root of both sides to get rid of that cubed. So this would be x is equal to, the cubed root of 0 is still 0. So we can't have x is equal to 0. So we would take what's in common between these two. So we would start with negative infinity, and then we go up to 0, but we can't include 0. And then we would put the little union sign, and then we start at 0 and go to infinity. So this is just saying all real numbers except 0. All right, so going back to 6, to find f of g, we would just take g and plug it into f. So we would have the cubed root of x cubed plus 1 minus 1. We can simplify this a bit. So we'd have the cubed root of x cubed 1 minus 1 would cancel each other out. The cubed root of x cubed would then become just x. For g of f, we would take f and plug it into g. So we would have the cubed root of x minus 1 cubed plus 1. So the cubed root and the cubed cancel out. We get x minus 1 plus 1. The minus 1 and plus 1 cancel each other out, so we just have x. To find f of g of 0, we just take 0 and plug it into our x here, which would just be 0. Number 8, to find the inverse of a function, we change our f of x to y, and then we flip our x's and y's. So this becomes x is equal to y cubed plus 2. We subtract 2 on both sides, so x minus 2 is equal to y cubed, and then take the cubed root to get rid of that cubed on the y. So we have the cubed root of x minus 2 is equal to y, which we change our y back to the inverse. So we would have f negative 1 of x. Number 9, find the inverse again. So we change our f of x to become y, and then we flip our x and y. So we have x is equal to the square root of 9 minus y squared. We need to square both sides to get rid of that square root. So we have x squared is equal to 9 minus y squared. Then we can subtract 9 from both sides. So we have x squared minus 9 is equal to negative y squared. We have a negative y, so to get rid of that negative, we would just divide both sides by negative 1. So our left side would then become negative x squared plus 9 is equal to y squared. And then to get rid of that squared on the y, we just take the square root of both sides. So this becomes the square root of negative x squared plus 9. And then we just have to state that it's our inverse, so we would put f negative 1 of x. Number 10. Determine if the function has an inverse. So to find if a function has an inverse, we just have to find the inverse. So we would change this, put a y, change our x and y, so we have x is equal to 2 over y squared, the square root of y. I'm going to multiply the square root of y on both sides, so it cancels out on the right, so we get it from out of the denominator. So we have x times the square root of y is equal to 2. To get our y all by itself, we need to move the x over, so I'm going to divide it on both sides. So I have the square root of y is equal to 2 over x. And then to get rid of that square root, I need to square both sides. So it cancels out on the left. I have y is equal to, we need to square the top and the bottom here. 2 squared would be 4, and x squared is just x squared. And then we change this back to our inverse, so this would be f negative 1 of 4 over x squared. X negative 1 of x is equal to 4 over x squared. So yes, this does have an inverse. Number 11, find the zeros of the function. So here when we have a number in front of our x squared, we need to multiply the first and the last terms together to begin. So we have negative 60. Now we need to find two factors of negative 60 that add and give us negative 7. This would be 5 and 12, and the 12 has to be negative. So we plug those into our parentheses. We have x plus 5 and x minus 12. And then we can't forget about this 2 out front, so we need to divide both of our numbers in our parentheses by 2. If it doesn't go in evenly, if it doesn't look pretty when it divides, we move the 2 to the front. So we have 2x plus 5. And then here it divides in evenly, so we just simplify. This will be x minus 6. Now this is equal to 0, so we just set both parts equal to 0. So we have 2x plus 5 is equal to 0, and x minus 6 is equal to 0. And then we just solve both of these equations. Subtract 5 on both sides, so 2x is equal to negative 5. Divide by 2. X is equal to negative 5 over 2. And then here we would just add 6 to both sides. X is equal to 6. For the next one, when we have a fraction, we don't even need to worry about the denominator because this fraction is going to equal 0 when our numerator equals 0. So we just set x minus 4 equal to 0. We can add 4 to both sides, so x is equal to 4. And the last one, we have 0 is equal to the square root of 2x minus 1. So here we can just solve for x. So we're going to add 1 to both sides. So 1 is equal to the square root of 2x. To get rid of that square root, we are going to square those sides. So 1 squared is just 1. So 1 is equal to 2x. Then we divide by 2. So x is equal to 1/2. Right, and that's everything for the review.